So for now, let's look at the definition of our big O notation here. So it says the definition is this one. Um, a function f of n is said to be the big O of g of n denoted by that. So f of n is equals to O of g of n if there exists a positive constant c and an n sub 0 such that this one. It satisfies this. Okay, so how do we relate this definition sa ato ang actual nga discussion so far? So we can just say that f of n here is our t of n. So that's technically a runtime and we will be finding out its g o of n. Okay? I o of g of n. Sana siya, what is this? And then we need to find unsa gid ato ang g of n, no? So big O, as I've mentioned kaganina, big O is your upper bound, right? So na siya sa taas perminte. So that's like the overestimate of your actual T of n. So our example so far states that our T of n, sa katong finding the sum of the list, is 2n plus 5, where n is equals to s, right? Right? Now let's look into this one and analyze it. Now n here is the number of input. Now if f of n is a t of n, then it means that n here is also your number of input, right? Right? So we can say, because it says here that there exists a positive constant c and n sub 0, and such that f of n is less than or equal to c times g of n for all n greater than n sub 0. If n represents the number of input, then we can say that our n sub 0 is equals to 1 because there's no such thing as an input that is 0. We will always start at 1. No? There's just such as counting kaganina nung nagsugod mi dito sa 1. Because n represents the number of inputs, we will start at the lowest value possible, which is 1. So in this case, our n here can be greater than or equal to 1 since n represents number of input, right? So now we have a rough estimate as to the value of n. Now, the next is we need to find the g of n and this constant c. So we still don't know our c and we still don't know our g of n. Okay, if we want to find the upper bound of our t of n, this one. Okay, so now let's write our t of n as f of n here. So 2 of n plus 5 is less than or equal to c times g of n, which we don't know yet. Now, class, when you look at the runtime of your algorithm, this one, your t of n, first thing that you will need to do, pinakauna, always remember, to look at the highest increasing na term. Katong term nga mo ay mo direct sa direction sa atong function. Sa atong pinakadali mo saka na term. Mo to ang tan-awan ninyo when you compute your O of n. If you look at this one, your T of n, this one here. Ni imuhang T of n, right? Ano siya? Now, unsa nga term man ana ang pinakapaspas mo tubo. If your n is equals to 1, your T of n will become 2 plus 5. So, this will become 7. If n is equals to 2, so duha na kabuk inyong input, this one will become 2 times 2 plus 5. So, this will become 4 plus 5. Right? If your n is equals to 3, if your n is equals to 3, so n times 3 plus 5, so this will become 6. Ay, 2 din. plus 5, right? So, kung tanawan na itong sa term ang pinakapaspas ni Dako, this is kani, right? So, as your n increases, this term also increases. Diba? So, as n is equals to 1, he should 2. When n is equals to 2, he should 4. Your constant, however, as its name suggests, it did not change anything. You know? Constant lang gihapon siya. No? So, in this case, your fastest growing term here is your 2 of n. Right? So, why do we need to find the fastest growing term? Because that will be how nato siya ma-estimate kaning c times g of n. Okay? So since 2 of n plus 5, we need a function here. This is technically a function also that is slightly above your 2n plus 5. We can estimate 2n plus 5 less than or greater than. So may slightly above ani. 5, we can disregard 5 because this is a constant, doesn't really change a thing. Wala may mahitabo sa iya as your n increases. We have here a constant 2 for n, so we can just assume, since 2 man ang constant ni n din niya sa atong fastest growing term, we can assume c here as 3. Diba? Slightly above this kaning atong 2 of n. So we can just see. And of course, our g of n. So again, the goal here is to find a function that is slightly above your 2n plus 5. And since we know that the constant doesn't do anything, we're just going to be focusing on slightly above 2n. So what is slightly above 2n here? That would be 3n. Right? Anong marag ko ano ganyan siya class? Anong common sense, kumbaga. Diba? So, technically, we can just say here, because we come up with 3n, we can say that c is equals to 3 and our g of n is n. Right? So, since we have our g of n in here, we can safely say that the big O of t of n is the big O of g of n, which is O of n. Ana ra. What? Ana ra din na, ma'am? Why may nagdula-dula? Now, we need to check this first. Kato kaganina na ako mention na n will always start at 1. We need to check this equation here that we have created if this holds true when n is really equals to 1. So, if n is equals to 1, we will say here 2, 1 plus 5 less than or equal to 3, 1. Okay, so 2n plus 1, that is 7 less than or equal to 3. Oh no, this does not hold true. Okay, so, ma'am, saan nini? This does not hold true. 3 is not greater than 7. So, if we do, ato na siyang i-graph here, 2n plus 5 at 3n, and then atong tanawon, ang pinakaganda here. We can say na this here, this equation, 3 of n here, or t, kaning ato ang kuha nga constant 3 and g of n na n, only starts na mo upper bound siya if n is somewhere here. No? Tanaw na to siya tarong, no? So, if n is somewhere here, usa paning 3 of n, matawag na to na upper bound ni g of n. Okay. Now, since we are assuming functions here sa ato ang program, sa atong code, and n will always start at 1, we need to conform to the rule that this should be true when n equals 1. Thus, this one here is not the correct upper bound. Okay? Though it is correct when n is somewhere, ang sa may value ka ni n ani nga mo correct siya. Any any idea? So here, according sa graph, it is at x equals around 15, right? So this will hold true if n is greater than or equal to maybe 15 or 13, somewhere there, no? But it does not hold true when n equals 1. Thus, this is not the correct upper bound if we do follow these rules where we will start at n equals 1. So, ma'am, unsa ang manin ako ron? What will I do? So, of course, we will conform to the rule na n is equals to 1. How do we do that? So, the next technique that you could do is this one, which is the usual technique that I usually do and sa kaning ako mabasa sa libro is that 2n plus 5 c times g of n, right? Here, I will assume that c is equals to 1, okay, and g of n is slightly higher than 2n plus 5. How do I do that? I do that by adding, by making the second term or the other term of the function as the fastest growing term. So, unsay pasabot na ko ana. I will let g of n be equals to 2n plus 5n. So, in this case, duha na ang fastest growing term niya. Si 2n na ug si 5n. Other than sa kato example na to kaganina, we just increase its fastest growing terms constant into 3. Right? So, technically, this is higher than 2n plus 5, but it does not conform if n is equals to 1. This one here, however, we will try. No? However, this one, we know that this is really above 2n plus 5 because this has two fastest growing terms, si 2n and si 5n. So, if we do that, 2n plus 5, 2n plus 5n, of course, because our g of n is a constant. So, sorry. Inversion function. Atong simplify. Okay, so now we have this form here. We're not gonna be doing anything more. Ato lang yung tanawon. 7 here can become your C, and n here can become your G of n. Right? Diba? So now you have C equals 7 and your G of n equals. Okay. Kana siya, class. Kani siya. Yung function. Well, let's look at that in a graph. But kung wala may graph, because we cannot really draw a graph kung mag-exam ta, we will check if n is equals to 1. If that equation holds true. So 2n plus 5 less than or equal to 7n. So 2, 1 plus 5 less than or equals to 7, 1. So this becomes 7 less than or equal to 7. Which is true. So voila, we have our solutions now, no? Meaning, this here, c is equals to 7 and g of n equals n is sufficient enough to become the upper bound of your g of n. And thus, we have our final answer that the O of the big O of this function is our g of n, which is sama O, and our c is 1, and our n sub 0 is 1. I no no no, c is 7, sorry. Let's check that on the graph. Okay. So here in this example, 7n as n is equals to 1. This is 1. That one there, nakita na to, mag-cross sila, and then right after that one, di na sila mag-meet. So this is a good estimate as to the upper bound of your T of n. Okay? So that's technically your big O of n. Big O, the upper bound of your T of n. So hopefully nakasabot. So see you on the next vid. We'll be talking about big omega the next time.